Hi everyone, are you able to hear me clearly and see my screen? All right, so yesterday, okay, so do you have any questions for me before we start? Hi Nada, hi Kush, hi Prashant, hi Ted, hi Arslan, hi Jamil, hi Prashant, hi Priya, hi Ramana, Stephanie, Sapna. All right, so before we jump into today's session, do you have any questions? Today we are going to go with the next step. All right. Any questions for me before we start today's session? No questions? All right. All right. Great. Uh, okay. So I'm sharing the notes. I'm sharing the notes for today. All right. Okay. So, all right. I think I will skip a bit. I mean, I'll bring the Java part a little before, and then we will talk about streaming. Okay. There is no single straightforward way of learning MapReduce. Let me just think for a moment. So we talk about, Ted's question is, for real project, are we still going to use some MapReduce or is it all Spark? It's going to be all Spark. Okay, it's going to be all Spark. All right, so let's jump in. Good, good. So yesterday we talked about MapReduce, whereby we were talking about Hadoop does the sorting and your reducer gets the data grouped by key value. Okay, I think I'll start with Java 1. I think that will finish very quickly. Okay, we will not go into too much of advance in Java. In MapReduce, we will try to restrict ourselves to the basics. We'll just get you all up and running with the basics of MapReduce so that if you want to go deep dive, you can anytime take a look at the slides or take a look at my previous videos and go deep dive. All right. Correct. Spark is more important. So we will try to increase the size of Spark sessions and we'll try to decrease the size of other sessions. All right. Okay. So yesterday we talked about that we can write our mapper function and reducer function. So the way you write a mapper in Java is by extending some basic class, okay? By extending a basic class called mapper. And this is the only piece that is important, right? Because here we are saying that we are trying to create a mapper which is abiding by the contract called mapper. So our step mapper is a mapper which is having this logic inside this function called map. So this is the piece of code that is only the mapper logic. Okay, so this piece of code where we are saying words equal to value. So what you see right now is mapper gets automatically key and the value. And when we are running mapper on a text file, when our input is a text file, the value is each line, okay? While key is the byte count, meaning which what is the sequence number of this line in terms of how many bytes it is away from the beginning. Okay, instead of saying line number, we are using byte count. All right, so here we get key as the byte count and the value as the line. That's what we get from Hadoop in our map function. And what we do inside this map function, we are saying take that value, convert it to basic string, split it by tab or space, okay, meaning every line gets broken into words. So this function is going to run on one line at a time. The value that you see here is a single line. Okay, so this single line get broken down into words, and for each word, we print out key and the value. The text and the long writable, these are kind of wrappers. It's like if you go to somebody's birthday, instead of giving the gift exactly just like that, you are wrapping it in the wrapper. Okay, so text and long writable is something which Hadoop has said that if you are giving me a string, give it wrapped inside text. If you're giving me a number, give it wrapped inside either int writable or long writable. All right, so so it's very simple thing that we're doing. Yeah, so instead of just passing the string, we are creating text class because Hadoop guys realized that the string class of Java was not great to transport over the wire. So they created new class which can serialize better. Okay, so because this data will get transferred over the wire, right? Whatever key value you are going to split into context is going to get transferred over the wire. Now question is there any use of this? Yes. Sometimes we may want to know what is the key. Okay, what is the line number of this particular I mean the byte count as in character count, at which character is this line existing. So sometimes we may want to use it. All right, this is 1. It's not I, it is 1. All right, instead of, we could also say 2, 3, whatever we want, because at the end of the day, all these values are going to group together for each of the word. All right, now that was the mapper's definition, whereby all we were trying to do is take the line, split it by tab, and then do the magic. Okay, we could do convert it to lowercase, remove special characters, or we could do various kinds of magics like reverse each of the word, put it out here, and so on. Whatever we want to write here, or send an email to people, or if this line contains a URL, download that data and put it in output. Okay, so you can do anything you want inside this piece of code. This is your mapper. You can write any logic you want. Question from Ted is, why are we writing 1? Correct? So question, we could also write anything here. Okay, there are two points to the two question two. The question from Tad is in two parts. One, why we have long writable class. Long writable class is Hadoop says that since I prefer gift wraps, so please bring anything to my birthday party in the gift wrap. And that's what is all these text, long writable and int writable, all of these classes are kind of wrappers. So before handing over the keys or the value to Hadoop, you wrap it in another box. Okay, that's what we are doing. We are creating a new text box, putting the word inside it, and then handing it over. The reasoning from Hadoop is that it's far more efficient. These classes are far more efficient in the data transport. Okay. Now, why one? Why not two? Why not three? Because so at the end of day, whatever values you give out here, they will be grouped by Hadoop together. Okay, whether one, two, or whatever. Even if you put like blank string, they all are going to get grouped together for each word, right? And therefore we just have to count those, the length, or count the total number of values for each key. All right, this will get cleared in the next slide of reducer. So you can see that in mapper we did not do anything to read the data. Hadoop gave us a single line. Instead of the whole file, it gave a single line and to the mapper. Okay, you can see that we are getting a single line here, and this is the key. Next is the long writable part here, you see. Okay, so we are giving out the key value in this form. Now you can see that for each line we can create many words, correct? We can create many words, and if we want, we can for each line we can have many words, and for each word we could have many key value pairs, right? Or sometimes we may prefer to give, we may want to give no key value. All right, next is so this is, and keep in mind that while we'll run this mapper, we will give the whole file, which means this mapper class is going, mapper function, this mapper function, you see this void map function is going to get executed for every line. If you have a million lines in the input text file, this map function is going to get executed a million times. Good? These are the important part to understand. Next is the reducer. Okay, next is the reducer. Reducer is you create your logic called reduce, have the key and the list of values. Okay, so this reducer function will be called for every key, not every line, every key. And all the values, since there could be many keys that have there could be some keys or many keys that will have multiple values, all those values will come together. Okay, meaning reduce will be called on every group of values for each key. If there are 100 keys in total, reduce function will be called 100 times. Okay, all the values for each key, each unique key we are talking here. Okay, so mapper gave many key values, right? They will get grouped based on the first parameter, this one. Okay, and all the values will come together, and for each of that group this method called reduce will be called. And here you can see that all we are trying to do is we are saying sum equals to id values for every value we are summing up. Okay, we are iterating, we are going through this list of values, and then we're going through this list of values. You can see that we are saying for long writable IW in values, sum plus equals to IW dot get. Now you can see that this is unwrapping the gift. Okay, IW is in the long writable kind of thing. Okay, it's kind of wrapped in long writable, and then we are using get to convert it into basic long and then summing it up. Okay, and then we are printing context dot write. And a question from Kush: is context maintained in memory? Very good question. So part of it is maintained in memory and then flushed into the disk continuously. Yes, the one is from the yesterday's examples. All right. So are these two classes clear? I know that it could be hard for the people who are coming from non-Java background because Java is a little too verbose and it's like too much syntax, and you generally get lost in the syntax. While if you take a look at it, it's only this piece of code. Okay, it's only this piece of code. All we are doing here is iterating over the values and summing it up and putting in the context. Okay, now, yes, so normally it gets triggered for every group of values and then gets reset. That's what you mean? Yeah. So reduce and map do not maintain any kind of a cache. All right. So important part to understand is whether map or reduce, they can do anything you want them to do. They can download a website. Imagine, imagine that. Okay. Let me ask you a simple question. Okay. Let's say you're writing a crawler. Okay. Or let's say download 1 million 1 million URL. Okay, so the input file would contain, yes. Let's say your assignment is to, okay, so every line in the input file will be a, so input file would contain URLs separated by new line, which means map function will be called for each URL. Now, what would your map function do? Yes. Yes. So it will basically download data for each value dot get, right? Value was the line, the argument. Okay, second argument. Okay, so it will basically download data. I'm just trying to, because we will do the similar exercises later as well. Now, what will reduce function do? In this case, let's say you have to download 1 million URLs. Or let me put it this way, do you need reducer in this case? Correct. Answer is no. We do not need a reducer. Good. And this is a very classic case whereby we would let this job just download all the data into HDFS. Yes, we may need reducers if URLs are not unique. Okay. Okay. But we may need reducers if the URL are not unique. We may, but that would be before that. If you want to prune URLs, You may want to remove the duplicates, but even 1 million URLs are not that big a deal for program to do it, because 1 million URLs means around 100 megabyte of data. That sort command of Unix can do that. Okay. All right. A question from Saptrishi is, all right. Okay, so Ted's point is, Ted is saying wow. So which part of it wowed you, Ted? Okay, so let me answer Saptariji's question. So this is not done parallelly. Yes. Okay, so Unix sort can do 1 million URL sorting pretty easily because it'll be hardly 100 megabytes. So you can simply sort the file. I'll not do it in MapReduce because it's not worth it. Okay. Okay. Now, where was the Okay, so Arslan, that's my next point I'm going to talk about. Just give me a minute. That is something I should have actually talked before jumping into answers. Okay, Saptarisi, just let me answer Arslan's question, then I'll talk about you. Now, so we created 3 classes. One is called mapper, other is called reducer, third class in Java, because in Java everything is a class. Okay, every class goes either in a single file or in another. Now, we create a driver. We create a driver which basically ties things together, right? In this driver, in the main method, we define something called a job. We define a job and then set all the parameters. Here we are saying that stub mapper, stub reducer, output key class, output value class, map output key class, and map output value class. And then we are adding these input paths. You see, we are saying file input format dot add input path job, and we are passing the argument whatever people are passing going to run this command with. We're passing the first file as the input and second file as the output. Okay, so that's an answer for Aslan. And then we are saying this is the line where we are actually scheduling the job for execution. All right. So we will actually do this. I'll suggest you a very easier way to do it. Okay. Instead of using Eclipse or doing anything, we will do it very easily. Okay. So this is one exercise which we are going to do just after this. Now, question from Saptarishi is, so this is not done parallelly. I mean, the system has to wait for the mapper to process each line and output before reducers start working. All right, very good question. Very good question. So who can answer this question for me? Let me go back to the diagram. Okay, let me go back to the diagram. So mappers are being executed. Your map function is going to get executed parallelly on multiple machines. Now, sometimes let's say you have 1 million URL. Okay. Let's say 1 million URL is hardly 100 megabyte. If 1 million URL is just 100 megabyte, that means it's going to have only one node, right? Therefore, in these kind of circumstances, we may want to force MapReduce to run on multiple nodes rather than on one node. In those cases, mapper will run on, let's say we forced MapReduce to run parallelly on 100 nodes. So in those cases, parts of the URL will be handed over to multiple machines. Okay, the input file will be broken down into 100 parts, and accordingly, that data will transfer. So that amount of transfer would happen. Okay, now question. So here you can see that these mapper functions are running in parallel and sorting the data parallelly. Okay, and the output. So in our case, in case of 1 million download case, okay, in 1 million download case, we don't have a reducer. Therefore, it would not wait for the reducer to finish. Okay, because the data would directly go from mapper into the HDFS, right? So, but in the case of merging, this sorted data, all the data from all the nodes need to be here in order to sort, in order for sort to begin. Although there have been fairly interesting optimizations on the reducer side, whereby even if it receives data from two nodes, it starts merging them before the other node has finished. So that when the other node's work would come, it will merge with the resultant. Okay, let's say out of these three, two have finished. Okay, out of these three, two have finished and sent to the reducer. It will start merging that data, and when the third one comes, then it'll merge the resultant and then start sending to the reducer. So yes, so reducer would basically, before your logic starts getting executed, it has to finish the merging from all the nodes. So it's only this merging part which requires everybody to finish. Okay, very good question. I hope it's very clear to everyone. All right. Did I miss anybody's question? Question from Sapna is, if this is not done parallelly, how does it identify the sum of counts? So this is done parallelly, okay? And identifying the sum of the count is not dependent on whether it's done in parallel or in sequence. It basically, for the sum of the counts, you will have to, the whole process has to finish. In that sense, it has to basically wait here so that all the values from everywhere come together. And that's exactly the reason, because it has to compute the correct sum of counts of all of the values. Therefore, all the values for a key from all the nodes have to be gathered. Okay, so yes, in that case, you are right that that reduce has to wait unless the counts come from all node, and then it computes the sum. Okay, did I answer your question, Sapna? Okay, question from Jitendra. Input file is supposed to be in HDFS, or it can be located on local. It has to be in HDFS. Okay, the driver is essentially logic which binds these, which defines the job. Okay, it tells who is your reducer, who is my mapper, who is my input file, what is my output file, and what is my data type of key, input key and input value. So the driver is the one which does the main stitching job, defining the job, and submitting the job. So driver is the main method of your program. All right. Mohit's question is, this will depend on type of reduction. Let's say we want to get an average, then reducer has to wait for all the mappers. Yes, that's correct, Mohit. Question from Jinyang is, does application master run this driver? Very good question. Who can answer this? Does application master of Yarn run this driver? No, actually. In case of MapReduce, it is run on the same machine from from which you are going to submit the job. While in case of our Spark, driver is run in application master, and you have the choice of shifting between the two. Okay, Kush, I missed Kush's question. How is it decided when you need to flush context value into the disk, or till what size context need to be maintained in memory? Okay, very good question. So I think this is a little interesting question, and I was avoiding this question actually, thinking that we won't need it. Okay, so there is something called we call it circular buffer. Okay, so and these are very important concept when it comes to architecting. And let me just pull my diagram thing. Okay, so what happens is from one side, all these key value pairs are coming in. Okay, so your mapper is giving the mapper is basically feeding the key value pairs. Okay, so from mapper the key value pairs are coming in. Okay, and from there on the other end of this one, the data is getting consumed. Okay, written into the disk. Okay, and this buffer is generally a circular buffer. Okay, so on one end of the queue, mapper is writing to it. On the other end, it's getting written into the disk. Okay, and this size of this buffer is something you can also customize, although there is no need to customize, but you can Hadoop map gives that ability, as in Hadoop MapReduce framework gives you that ability. Okay, so is it clear to you, Kush? All right, so that's the model. Okay, so question from Manjunath is, what do we set in the conf? Conf is an object which is already there. Step driver knows it. It's kind of an environment that is when you launch the job, all the values of the current configuration will be loaded into conf. All right. So Sundar's question is the buffer size dynamic? Yes. So, okay. So generally we don't configure it to be dynamic because instead of it consuming entire memory, let it fail. Okay. I mean, it doesn't give you the option of making it dynamic. Because the reason why buffer will overflow is when the writing would take too much of time, which means the disk is corrupted or something is wrong with the disk. Okay. All right, so let's try to run. I'm not going to go into details. Let's just all of us try to just check out the code. Okay, so this is my repository. Okay, here are the steps in order to. So GitHub is a place where everybody generally puts their publicly available code. And I have also put in the repository of MapReduce example here. Okay. Also, yeah. Also, I have put one more repository for Spark related work. Okay. I'll share that with you. Okay. So this is the repository, and what we have to do is basically clone this, meaning pull the data to your local drive. And when you pull that, you will get the folder called MR examples created, and that's it. All right, so I'm going to open my CloudX Lab and remove. I'm going to remove my old data from it. My lab. Okay, so I'm going to open the web console. Let me decrease the window size. No, on the do it on the CXL, because all the compilers and everything we have installed already. Okay, so here I'm going to remove MR examples, or just move MR examples to MR examples to MR examples. All right, now let me just say copy the first command. Okay, so is everybody on this page? Okay, so open the console. All right, open the console and open the MR examples. Sapna, so are you able to open the GitHub page? I have pasted the URL in the chat earlier. So copy the command from there. That'll be better, Priya. So take this URL. I'm going to give this URL, and you will open that in the browser, and then take the commands from there. Yes, everybody with me? Great. All right. So this is my MR example, and here is. All right. Okay, so I have, you know, all right. So I've gone into the folder called MR example, and then I'm using a command called called ant jar. Ant is a command that basically builds the project in Java by reading build.xml from the current folder. So it says the build is successful, and this is where it has capped the, okay, it has capped the output. Okay, Sapna, at what point are you stuck? Are you able to open the GitHub repository and the console? Okay, what error are you facing? Not able to log in? Okay, okay. You can share your screen. We can help you. Okay, it'll take like a few minutes. Okay. Okay. Can you share your screen? Yes, I have stopped sharing so that you can share. Okay. So who all got build successful? Okay, great. All right. Can you open the console? No, 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 you go into no big data first. Go into no big data, log in uh, in the browser. Can, yeah, nobigdata.com/mycourses. Just log in into. I can't see a screen. I think you have only shared one browser window. Okay. Open no big data. Or what we can do, Sapna, is if after the class you have some 30 minutes, I can, help you with the logging in. Are you able to, have you logged in into my courses? Do you see the my courses and then web console? And I was not able to see your screen. All right. So console. All right. Do the first command. Take the first command from the GitHub. This is the first command, git clone and the URL. Take that. Okay. Take this, go into MR examples, and then do ant jar. This is first command. Copy paste and press enter. Then second command, third command, and press enter. Okay. All right. So Sapna, are you there? You can unmute yourself for time being in case you're having problem with too many windows. Yeah. Yes. So are you able to log in? There's too much of noise coming in. What? All right. So we can hear a lot of noise, but we can't hear your voice. Okay. So I've muted you because there was a lot of noise and we could not hear you. If possible, try sharing a screen. Yeah. So first run the clone, then run, go to this folder. Are you able to build, is it built successfully? Do you see this screen? Great, great, wonderful, wonderful. All right, so we have been able to, all of us are able to build it. Next is that we run this command. What does this command do? It basically executes the driver Hadoop jar, then the location of my jar. You see, this is where it was built. Okay, so we are saying Hadoop jar build slash build. Why we are saying build slash? Because it is relative to my current folder. My current folder is this, and this location without the slash is the location with my jar. And then we are saying my dot step driver. This is the name of the entry point which is packed in the mr.jar. Okay, you want to see the code, you can go to src and take a look at the code. Okay, here, this is the step driver. This is the entry point that we are trying to specify. Okay, then, all right, next is, go back here. Then we are saying this is the input directory. This is the output directory. Okay, this is the input directory. This is the output directory. Let me try to execute it. Okay, it says that you can see that it says that the output directory already exists. Okay, Mohit is saying that can you elaborate on the entry point, because entry point means this is the class that is going to kick in the job. Okay, it will define who is your mapper, basically tie things together, right? If you take a look into the code, you will get the answer here. If you go into src, then you can see that. So this is the main method. Okay, it basically creates the job, then it does the other parts. Okay, all right, so that's it. Now it is saying that the folder already exists for me. Why? Because there is already, I have already run it. So all I will do is I'll just delete this. And how do you delete? All I'll do is Hadoop fs minus Hadoop fs minus rm. Okay, but it says that it's a directory, so we will have to say rm minus r. All right. Also, please note that there's an interesting part to notice. A question of Priya, do they have more, or anything can be reduced? Anything can be reduced. If you want, it is up to us, up to our business logic to decide. What was the last argument in the Hadoop jar command? The last argument is the output folder. So after this point, all these arguments are going to the driver. Okay, going to the driver, and driver is picking up these argument 0, argument 1, and then pushing that to the input directory and output directory. Okay, so now you can see that this has executed and it shows all the statistics of MapReduce. If you want to take a look at what is there in this, either you can go to, let's say, Hue. Okay, you could open Hue. All right. All right. So yeah, here is the folder. You just sort it by date. Good. Now you can see that this is where the output has been saved. See that? Good. Since there was only one reducer, there is one file. Okay. If you want to change it to two reducers, it's pretty straightforward. You can go to the console. Okay. All right. This is my source code. I go to src. I go to my, right. I go to my, because that's the one we are using. What were we using? We are using my.stepdriver. So there will be my folder. In that there will be a class called stepdriver. Okay. So I'm going to use nano, and I'm going to add it step driver, and in this I'm setting the number of reducers. Okay, how do you set the number of reducers? Okay, it's not mentioned here. So what we will do is we will say job. Okay, so job dot, okay, let me set reducers. Okay, I'm just searching for Google because I'm not running inside Eclipse. Had it been Eclipse, okay, had it been Eclipse, it would give me a suggestions, quick suggestions. Okay, so in the driver itself, all right, let me just, or can kick in that. All right, so there is a library here. It's called set number of reducer to. I think this should generally do. Okay, so I go up, I say ant jar, go one more up, say ant jar. Let's see, do we get an error? It says yes. Okay, it says that the method is not found. Okay, so let me take a look at the API. I have completely forgotten. Yeah, this is the one. Nano, and I say src slash my slash step driver. Yeah, thank you, Manjunath. Okay, so now, so here we have enforced the total number of reducers by our side. Okay, so now we are saying one. So there will be new folder called Java. This, it says the output directory, this one exists. So let me delete it. I'm deleting that folder. Okay, I'm running the command again. Okay, so why I have deleted? Because otherwise it gives an error. It doesn't overwrite the existing output folder. Instead, it gives an error. Hence, it's a safe design choice because let's say there are multiple MapReduce jobs writing to the same folder. In that case, they will overwrite each other's output. Okay, so this project is written in Java just for the example sake. So everybody is able to run it and can see the output. Okay, now you can see that there are two parts to it. Okay, which means earlier we were running this. Okay, only one file was there. And now, earlier we were running this. Now we are doing this. There are two files that are being created. Okay. Okay. So this is the code is written by me. Okay. While the code is built by you. Question from Saptrisi, where is the file name part written? These are written in the HDFS. Good. I have missed quite a few questions. Um, one question was from Priya. Do they have more? Okay, more or anything can be reduced if they are, which is optional. Uh, okay, so did I answer your question, Priya? A
Yes,
question?
you did.
Okay.
More is there, but what is the mandatory that I missed? Is
Okay.
there anything mandatory?
So mandatory is you have to define mapper. Mapper is mandatory. Okay.
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 And somewhere it's documented?
Yeah, it is documented in the MapReduce driver documentation. Uh,
Okay. Can you just send me the link? Thank
yeah,
you.
just search for the MapReduce documentation. I think it is there. All right.
Okay.
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 You can try to tweak this MapReduce code, okay, whatever I've shared, to solve your problems. Okay. You try to tweak that. Next question was from Saptrisi. What was the last argument? I think I have answered that. Code has been written. Yes, this is answered. All right. So this one is not written in Scala or Python. All right. This is just to give you a good head start into MapReduce so that everybody is up and running. All right. So that was the MapReduce in Java. I hope that's good for all. All right. So moving ahead, I'm going to talk about this was. All right. So this is good. And okay. So in case of, yeah, go ahead, Thomas. A question from Thomas is to merge the two output files, what do I use? Okay, one easier way is, okay. So one is that you take it offline and merge it there. That's one crude way. It's a very interesting question, and let me try to answer it in multiple phases. Okay, let's say there are two parts, part 0, part 1. And then what you want to do is you want to merge it. Okay, one is take it offline and merge. Okay, I think Hadoop has also given a command. Okay, Hadoop fs, and I doubt. Okay, this merge is not that much. It's a different one. All right. So take it offline and merge it. The second is use Hadoop fs minus cat and then part this. But this will be local file. Okay. So while part is your, okay, let's say my output folder slash this. Correct? This is first attempt, second attempt. Third is you need to think about why are you merging it? Why do you want to merge it? Because the input can be a folder. If let's say you want to run another MapReduce job or any other kind of processing, you could always run from bunch of the files in a folder. Okay, input can be a folder to other processes. All right. Second is after merging, let's say the way we are doing right now, the word count problem, if you see here, there is a problem in the output. If you concatenate it right now, let's take a look at it. Okay. So this is a very important question. I want to answer it again and answer in the parts. So what you see here is some words. Okay. And after this point, they are ordered. Okay. I'm going to put them in two text files. This is one text file. Okay. And this is another text file. Let me pick the initial words from the another part. All right. Now, do you see something very strange? Even though part 1 and part 2, part 0 and part 1, both are sorted, you can see Adele, adorable, adored, and so on. And second part is also sorted. But when you combine these two, concatenate these two, the result will be wrong. Correct? The result will be long. Now this is no longer sorted. Therefore, you have to be little cautious. Okay? If you're trying to achieve an overall sorting, then you will have to define something called partitioner in using your Java code such that let's say all words lesser than j go into first file and great greater than or equal to j go to the second file, and then you can happily concatenate those two. Okay, so concatenation is a decent difficult problem. Okay, while we want to run the reducers in parallel so that they create their own files so that they don't have to wait for each other, at the same time merging those two files could be a challenge at later point of time. All right, did I make sense to you? Okay, so other part I want to mention in the file is, I'll just close these two. All right, let me just close it. Okay, in case you are concatenating, keep in mind the data may not be sorted as per your wish. Okay, sorted, you might have to decide partitioner. Okay, so partitioner is nothing but a class which can tell whether to send a particular key to first reducer or second reducer. Okay, that can be written in Java, and you can take a look at how to write by looking at the code in this repository. Okay, so here here if you go into this, you will see step partitioner example. Take a look at that. All right, it's a fairly decent complex exercise. So under SG you will find the advanced map reducer. Okay, those who are interested can take a look at it. All right, good, good. So Nadal's question is, HDFS, DFS append to file, is it merging? This merge basically does it to the local, from local to the HDFS. Okay, so you can take a look at that. All right, so you can see SRC and local destination. So get merge means get the data from HDFS into your local folder. Okay, Arslan, I'll answer that question soon. Okay, okay. A question from, so append to file again is, you can see where is the command called append to file. I want to take a look. Yeah, in this append to file, you are appending local file to the HDFS file. Okay, multiple local files into a destination file. All right. So there was another question. All right. A question from Ted is, in our diagram, okay, in our diagram, the merging is not automatically done by HDFS. So we have to specify it in mapper or reducer. So in our diagram or anywhere, whenever we are having multiple reducers, or if there are no reducers, okay, so there could be three circumstances where you have multiple mappers and there are no reducer. In that case, there'll be multiple files in HDFS. Second is when you have multiple reducers where you will have multiple files. If you have multiple mappers and single reducer, there'll be a single file and so on. Okay, so so basically, whenever either you have multiple mappers and no reducer, then you will have multiple files in HDFS. And the second circumstance is when you have multiple reducers, then you will have multiple files. And if you try to make it a single reducer, then your overhead on a single reducer will happen. Okay, there'll be too much of work one reducer has to do. Therefore, based on the load, based on the data, you decide whether you want a single reducer or multiple reducer, and then lay out a strategy such that when you concatenate these files, the data is in the order that you want it. The reason for 5 digits in output file, because there could be up to 1,000 reducers. Okay, around 10,000 reducers is what they have planned. All right, that's the reason they have like 6-digit number. I don't know what happens when they reach say 10,000. A question from Saptrishi, where can we see the map functions output? We can't. It's a temporary file created on every machine running mapper and that get deleted after the job is over. All right, good, good. Now moving ahead. So a question from Arslan was that can we do it using the say scalar? Okay. Yes, Jamil, we can see the mapper's output in that case. Very correct. Thank you. All right. Now, so There are many kind of programmers in the world, and there are situations where you cannot really change a particular program. So question is, can we use MapReduce in those cases? Answer is yes. That's what Hadoop MapReduce guys did. What they did was they wrote a library which takes the input from HDFS and basically run any binary as a mapper and any binary as the reducer. They further simplified the model. They further simplified the model such that your mapper should accept the data from the standard input, just like pipe, just like the way Unix command accept the input from a standard input. In the similar way, if your program can accept the data in input, standard input, okay, then that can be used as a mapper. Similarly, your program should spit out the key value pairs in the standard output, and key and the value should be tab separated. Okay, similar, and reducer does not get the data grouped. Instead, it gets the standard input. It gets the data in the standard input in the it's sorted, not grouped. Okay, the input that goes to reducer is sorted, not grouped. All right, now let's take a look at what's going on. So here is a command, Hadoop jar, then the streaming library. So somebody wrote the Java MapReduce for you. It's kind of a wrapper which executes any command as a mapper and any command as a reducer, and takes all the argument. It takes all the argument, like how many reducers, how many mappers, whether you have a partitioner and not, all of this in the argument to this command. So we are saying Hadoop jar, and then we are providing Hadoop streaming.jar path, and then we are providing the input folder in the HDFS and output folder in HDFS, then the mapper command on the reducer command. So you can see that we're passing sed in the mapper command. Okay, Kush, is it clear now? So your program, what you call mapper, should read the input from standard input line by line, and then it should give out the key values onto the standard output. Your program, there are three streams in Unix. One is called input stream, other is output stream, and third one is error stream. Okay, so your program who is reading from you when you type from the keyboard, okay, that's called input stream. And when the program prints onto the screen, it's called the output stream, or if a program is giving an error, that's called error stream. So your program is supposed to read from a standard input and give out to the standard output. All right, so which means that every Unix command can be used as a mapper and reducer almost. Okay, now you can see that. All right, so we are using sed command, right? So sed command, what it does is, whatever input line it is given, it converts that into this, right? We have tested it already. If we say echo, sa, re, saga, and pipe, sed, substitute space with new line, we will get this. Correct? Correct? And then Hadoop will order this data, and output of this one will go to unique -c, that is our second command, and we will get the word count in the output. All right, in case you have multiple reducers, so some of the outputs, the philosophy will remain same. It's just that before calling your command, Hadoop streaming ungroups the data and sends it to your command. Okay, Sometimes we may want to ship the script. Let's say there are many commands and you want to bundle it together. So you make it a command and ship it together by specifying as file. Okay, you can specify it as a file and send it over to the network. So that, because other commands like unique and sed, they are already there on every node, because every node is having Unix, and we have made sure that we have those commands are available. So except this mycmd.sh, which is my command, therefore we have to ship it by saying file. All right, so let's try to do this, all of us. Okay, and then it should be clear to everybody. All right, so here we go. All right, let's see if it gives error. It says the output folder already exists. Okay, so let me say Hadoop fs minus rm minus r. I've deleted that folder. Now we're going to execute this command again. We're using, we're leaving Hadoop, the choice of number of mappers to Hadoop and generally based on number of blocks, it decides how many. Okay, sorry about the command. All right, let me go back here. Where is the command? So it seems to work fine. All right, so this seems to work fine. And let me check the output. There should be a directory called word count underscore output Unix. So let's see. Okay, so you can see that. So there is one file. You can see that it has computed the word count. Although it's not clean, but it has done a decent amount of work. Okay. So this is how it's working. So first SED will convert every line into one word per line, and then Hadoop will sort it. After sorting, unique minus C command, the reducer will be called on the data and it'll do the word count. Okay, is everybody with me? So Hadoop first fed our command line by line, okay, and then output of the mapper was sorted, and then for the whole output, our command was called. Good. So number of mappers by default is a function of number of blocks. Right now, since our file is very small, therefore there is only one block, and hence there is one mapper. So we can actually force it to use multi-mappers. Okay, did I miss anybody's questions? A question from Saptrishi. The driver class does not need to designate a mapper or reducer in this example. So the driver is actually written by somebody in this library. This library, what we are using here, okay, the library that we are using here, sorry, yeah. So the library called Hadoop-streaming, this library contains that logic of driver, okay? It creates the driver based on the arguments we are passing. You should take a look at more detail about the documentation here, okay? Okay. A question from Priya is,
Hello, can you
yes,
speak?
yes, yes.
I tried to run the command and everything is working fine, but then I go into the folder, even the previous command with the same thing. The
Mm-hmm.
command ran, but then when I go into my home folder, I do not see it. And I thought it could be an error. And
No,
then with
hold on,
second
hold on,
command
hold on, hold
again,
on, hold on,
yeah.
hold on. Yeah. So can you, yeah. So a little thing here. So you are actually checking in the local folder, not in HDFS. The output is created in your HDFS. So if you go into your hue, you should see it there. Okay.
So in my view, I am in going to the D only, and then it is not going to the actual page. My page shows empty.
Yeah.
There,
Click on
okay,
home. Yeah.
home.
Yeah. Click on home. Then it should show you. Because by default, they'll be empty. There are two file system we are talking about. One of the machine that's running this console, and second, the HDFS.
Okay, thank
Okay.
you.
Can you
Thank you.
see it now?
Yes, I can. Thank
Okay.
you.
Okay. All right. Please feel free to use the chat. Okay. All right. Good. Great. Great, Priya. And all right. So everybody is in sync. Great. Great. Wonderful. So we are all able to do the hands-on on both the streaming job as well as the the Java part. All right. So and great set of questions. Wonderful, wonderful. So streaming is a very simple way of programming. Even though I'm pretty good with Java. Okay. As I've been coding in Java for like 10 years, 10 to 12 years. But still, if people ask me to instantaneously do MapReduce, I prefer Hadoop streaming. The reason is the headache of compiling, creating too many files is not there. Okay, as you can see that when I had to clean up the data quickly, I basically wrote the whole script using shell and then ran that script as the mapper. Okay, so whether you are coding in Python, Scala, PHP, anything, if it can run on Unix, it can be used as a mapper or reducer. All right, if it can run on the machine, and remember, whenever you're coding any Unix script, the first line should tell let's say I'm writing a Python program. In case of Unix, it doesn't care about the extension, unlike Windows. Okay, so I'll give you the demonstration because this is a very important aspect and we missed this. Okay, so I'm going to create hello.py. Okay, sorry, I'm using vi. It might, some of you may not be comfortable, so I'm using nano. Okay, so here if I say hash exclamation bin dot bash, okay, and I say echo hi, all right. So this is my first program, even though its extension is Python, but I've written in in the shell, okay. And before I run anything in Unix, I have to say chmod plus x, okay. Now I can say dot slash hello dot py. Good. Although the code inside hello this program is not is not Python, okay. But if I say here that this code is in Python, okay, then it'll start giving. So where is the program? Which Python? The location of the program, it says bin Python. Good. Now if you see, it'll give an error. It says invalid syntax. So it's not the extension of the program. Instead of extension of the program, Unix tries to infer from the first line of the file that how to execute rest of the file. Okay, did I make sense to you? So when you are writing a mapper, make sure it is chmod plus x, which means executable, and first line of the file should contain hash exclamation, the location of your program, the interpreter. Okay, if you have, let's say, C binary, there is a C program which is a binary program a.out, and you want to run that as a mapper or reducer, you can run that happily. Okay, just that you have to say minus file and the program. Yes, Ali, that's right. Okay, wonderful set of questions. So this is how you do the map reduce. You churn massive amount of data just by using your shell script, Python, Perl, or any other scripting language happily. The difference of execution would not make much of a difference because it's distributed. The bigger work goes in the assembling things than the delta between various programming language. Okay. Yes, the minus file means we are shipping this program because this your mycmd.sh might run on a.cloudxlab, b.cloudxlab, c.cloudxlab, e.cloudxlab, and there it does not exist already. Therefore, you need to first copy it there, and the way you hand over this to Hadoop streaming is by using minus file. In case of Java, if you're writing MapReduce, let's say you are using JDBC driver or you are sending Java mail, using Java mail, then in that case, you will have to use minus uselib and pass on all the list of libraries that you can. Okay. A question from Ali is, can you run the whole thing with a shell script, for example? Say, do you mean to say that without MapReduce? Yes, that's what we did yesterday. Okay, so if you take a look at the command, I would like to say, all right, this is the command, right? This is the command where we have mapper is this, reducer is this. If I have to do the same thing, I'll say cat big.txt, okay, or cat star.txt, then pipe the data to, okay, SED, and then pipe the data to sort, then to this. So if you are coming from the same example that we did that day, where we said cat big.txt, and then SED, and then sort. So you can see that Hadoop streaming is nothing but a replacement of sort. Okay, and if you run this, command, you're not going to talk to Hadoop. You're going to run it locally. Okay, and if you, let's say more. So what I'm trying to say is Hadoop is nothing but this replacement for this sort command, plus this big.txt will be read from HDFS. Okay, so I'll show you the same thing. What has been done using Hadoop can be done in the same way. Okay, you can see that. All right, this is what you meant, Ali. Okay, so when I'm running any command here, it doesn't mean I'm running in Hadoop. I'm just running on e.cloudxlab.com, which is a Linux machine. Okay. Okay. Wonderful. Wonderful. Arslan's question is then why there is a myth that you should know basics of Java to work. So that's a myth actually. Okay, because sometimes you might need to customize it, and somewhere when it all started, MapReduce with Java came first. Okay, therefore that whole knowledge is going round and round. Okay, so when I came into the industry and I realized that when I delivered first class somewhere, I was going through their slides, they were still teaching the whole Java thing, because Java is good in the sense that you can customize a lot of things. But in real life, you don't need that much customization. Okay. Most of the libraries are already written and you can, do away with streaming. I mean, I wrote the whole recommender churning 200 terabyte just using Python. And Python was, I mean, that was my first project in Python and I did it in like 10 days. So this interesting important part to use the script in case of real data churning. All right. So basically, you can have no reducer. Okay, you can just skip the reducer part completely. Second, in case you want to avoid the sorting entirely, you can pass on an argument called mapreduce dot reduce task equals to 0. That way there'll be no sorting at all. And number of mappers will decide the number of output files. Okay. And number of mappers is a function of input splits, and you can configure that either by using conf.set number of map tasks or by passing an argument to the steaming job in this way. Okay. Now, number of reduce, somebody has already asked this question. Number of reduced tasks is something very tricky. So some people have empirically computed that the number of reduced tasks should be a multiple of some number between 0.95 to 1.75 multiplied by maximum number of tasks. What is maximum number of tasks? Maximum tasks that can be executed per task tracker or per container, a number of containers that can be executed on every node manager multiplied by node, meaning how many things can be done on the cluster simultaneously. That's maximum number of tasks. And the number of reducers are generally a multiple of 0.95 into max task to 1.75. Okay, so more reducers means the work will be faster because more parallelisms will be there. Okay, and more framework load will be there because there a lot of network transfer, and it lowers the chance of failure. All right, so that's pretty much about Hadoop MapReduce. Okay, and those who are interested in MapReduce problem solving, I think we'll move these problems to I think Spark. Okay, because let's try to solve these problems in Spark. Okay, we'll move these problems to Spark. Let me make that my to-do. All right, though it'll be easier and more meaningful that way. All right, so we will talk about Hadoop problem solving later. Ouch. Okay, now that's pretty much about MapReduce basics. There is an important part that I would like to discuss, and that important part is the input formats. Okay, so let's take a break for 10 minutes and back by All right, so should we start now? Is everybody back? Great, great. All right. So I think now is a good time to go over a quick question answer session. Is everyone ready for the question answer sessions? Awesome. Yes, all chats are saved. Do you guys want those chats? I can put it somewhere. Okay, I'll share all the chats. Let me put it in my to-do list. Okay. Yeah, I too will have a track record. Yes, that's right. All right, so I was going to talk about, just quiz you a little bit. Okay, so the data generated by mappers is given to reducers and then stored and shuffled. Yes or no? That's right. That's right. It's a big no. Okay, so the mappers, next question. The mappers can only generate a single key. The mapper can only generate a single key value pair for an input value. True or false? Yes. So for single input value, in our case was a single line, right? In the word count example, it was a single line. And we were generating multiple words out of it, multiple key value pairs, right? So the mapper can generate multiple key value. Therefore, it is false. All right. Next question is, mapper always have to generate at least a key value pair. Correct or wrong? Can mapper choose not to generate a key value pair? Let's say there is a file which has some of the lines in the file are empty. Mapper chooses not to generate a key value pair. Can, okay, that could be a case, right? A mapper always have to generate at least a key value pair is wrong. Okay, it is wrong because mapper can choose not to generate a single key value pair or can generate many key value pairs. It all depends on the code. Thank you, Saptariji. Good, good. All right. By default, there is only one reducer in the case of a streaming job. Yes or no? By default, there is only one reducer in case of a streaming job. Yes, by default, if you do not specify number of reducers, then it is 1. Okay. Now, in Hadoop 1.0, what was the role of job tracker? A or B? A question from Mohit is, but there might not be any reducers. Yes, that's correct. So in the case when you don't choose to specify number of reducers, the default value is 1. Okay. Yes. So the job tracker's role is correct. The answer is B. All right. Next question. Okay. The next question is, map logic is executed preferably on the nodes that are that have the required data. Yes or no? Yes. So all of you are right. So the map logic is executed preferably on the nodes that have required data. This is called data locality. Okay, good. Thank you, Ted. Next question is, now this is a little play on the words. The map logic is always executed on the nodes that have required data. Correct or wrong? Yes. The answer is wrong. Because because it could be that all the nodes on which your data is there, they could be all the nodes on which data or the copies of the data that block are busy, and therefore your map logic would be executed nearer to the data. All right. Where does Hadoop store the result of reducer? HDFS or local file system? Yes, it is stored on HDFS. Wonderful. Next question is, next question to all of you is, where does Hadoop store the intermediate data, such as if there are reducers and we have mappers and reducers both, then where does the temporary data of map tasks go? In HDFS, local file, or in memory? Or, okay, the intermediate data where you have both mappers as well as reducers, does it go in HDFS or local file or memory? Yes. So this time only Saptarishi is correct. Okay. It is first in the memory and then flushed out to the disk. Okay. It's the I answered this question when you asked. So first the output of map task stays in the memory and then is purged or flushed to the disk. Okay. Is everybody able to hear me? Kush can't hear me. All right. Wonderful. Wonderful. So is everybody with me on this? It's purged to the disk, to the local file system, meaning it's not on the HDFS, it's on the machine which is running map task. Okay. So it is purged as soon as the buffer is full. Okay. So on one end, the data from maps is going in. On the other end, it's being flushed out into the disk. And why is it so? So that both the works could happen parallelly. Mappers are executing parallelly, and the data is getting written into the disk parallelly. Okay. So how long does it stay in the local file system? For the duration of the job. As soon as job has finished, it is deleted. As soon as this data is received by reducer, the work is over. All right, good. So this was our, quick recap of what we have learned so far. Now, few more questions. All right, here we go. This is a very important question, and I don't expect correct answer from you, but all of you should try to answer. Okay, the whole of the HDFS block available on a node is fed to the mapper, or mappers are called exactly on the whole block available on that particular node. Yes or no? Right. The input is split using input splits, and part of which is transferred to other mappers. Okay? Part of which is transferred to other mappers. All right. Here is another example. I like to discuss this. And all right. Okay. Now, let's talk about a very important problem. And this is how we generally generate. So when you type on your Android keyboard, when you are typing a message, and when you type happy, it automatically gives you the suggestions like birthday. Let me actually open my keypad. Okay, or let me take a case of some random number, random name, and so when I'm typing happy, okay, so I'm seeing three suggestions. I'm seeing three suggestions on my screen. One is new, other is birthday, and third is four. Okay, third is 4. All right. So how can I quickly send it to all of you? Never mind. So all right. So when I'm typing on your keyboard, you can try typing a message and say happy. It'll quickly say new, birthday, or for, right? Similarly, if I type say how, it suggests me the next three words as much, too many. Yeah, right now it is MapReduce only. I was thinking of showing you my screen. Let me see if it comes out. So do you see my screen? That's my phone. All right. So as I'm saying how, it's suggesting much, too many, right? And if I'm saying happy, these are ads, happy new birthday for, correct? So it's giving me suggestions. You can see that these are the suggestions it's giving me. All right. So imagine that you have to do the same thing. Imagine you have to do the same thing. Okay. Imagine that, let's say, as part of your assignment, you have to give these kind of suggestions. So there are two parts to it. One, building such a keyboard or the application. And second part is building the dictionary. So here we are going to talk about building the dictionary. And this is called, I think this is called n tuple problem. Okay. And it's a very important problem to solve, because this kind of problem, because the data that we churn for this kind of result, it has to be big, because if it's small, you may not get great results. The bigger data you have, the better results you will get. Okay. Therefore, here, if you take a look at the Wikipedia's content, you can download the data from there and try using MapReduce to generate top 3 word recommendations. Okay. So although we will attack this problem again using Spark, but for now, let's try to just try to imagine how we will solve this problem using MapReduce. Imagine that the text which we have downloaded from Wikipedia or entire chats looks like this. How are you, Ram? Ram, happy birthday to you, and then Happy New Year. So we converted this text into key value pairs. Our mapper would convert this text into kind of key value pairs. Say, how are you, Ram? Happy birthday. So that every word is a key, and the following word is the value. So that when Hadoop groups this data, by the first word, all the following words will come as the value together, and then you can find out top 3 words from that list. Okay. So top 3 words you are finding in the reducer for every word. Now, question to all of you is, do you see problem with this approach? Is the approach clear to all of you? What we have done is we have formed the pair of the words. Every 2 consecutive words we have formed the pair, so that when the Hadoop groups the data by the key, every word as a key and every following word as the value, for every word in the reducer, we will compute the top 3 following words. Okay, so question to all of you is, do you see a problem with this approach? Yes. So answering to Jamil's question, so reducer will get how, and then there is no other words. So a reducer will get how, comma, only R. Then next key would be R and only U. And same is the case with Ram and Happy. And in case of Happy as the key, there will be birthday, comma, new. All right. That's what reducer will get. Yes, that's correct, Karthik. So there are 3 problems with this. One is, yes, that's correct, Mohit. The context is not being considered. Yes. So because one word could mean many other things. Okay. So the problem associated with this approach is, one, computation of frequency is too difficult to be done in the reducer. We'll talk about it later, how to solve it. Second is the last word of the line should pair with the first word of the next line. That did not happen. You and Ram and birthday and two should be paired, but it did not, right? So instead of new line being the separator, it should be the dot or dot space that should be the separator. Okay. Now this is something which I'm going to discuss because this is something that's used by Spark as well. Therefore, we need to understand this part clearly. Okay, this part need to be understood clearly. All right. So we have been talking about. So we'll talk about how do you solve this kind of problems. Okay, but this kind of problem can be solved by using various kind of input split rather than simply text input split. Okay, so now let me discuss in detail how do you generally transform, how does the Hadoop transform the raw block of data into something meaningful. As we discussed earlier, that the data is cut ruthlessly by Hadoop, by HDFS, into fixed size of blocks, right? The data is cut ruthlessly into fixed size of block, irrespective of what kind of data we have. Correct? Is everybody with me? Because so feel free to ask questions because this is something that's going to be a little confusing if it goes out of the line. So the HDFS is something which contains the block, right? While when we were talking about mapper, it was getting the full line as the input, right? When mapper is running on a particular node, it is getting full line. There could be a scenario where the block is cut in a way such that half of the word is on one node and half of the word is on another node. It might be the case that in case of multi-byte character, half of the character is in one machine, half of the character is on another machine, in another block. And so to solve this kind of problem, this something called input splits are created. Input splits basically translate the input format, tries to understand the block boundaries and then translate them to meaningful result. Okay, so the general strategy, let's talk about, so this is clear, right? Because at the top, while we have input split, here imagine that there are 11 lines of text. Fifth line is on the first boundary, which means first block is having 80% of fifth line and 20% of fifth line is in the second block. Same is the case with ninth block. Ninth block, approximately 90% of ninth block is in second. Approximately 90% of ninth line is on first machine, while 10% of ninth line is in third machine. Okay, this example is another example. It's not same as the diagram. Now this piece of data that you see here is transmitted to first input split. Okay, even if the bigger part of fifth block was in the second block, bigger part of fifth line was in second block, still the data, this extra block will get transmitted to the first node. Okay, when mapper is running, input split is getting created. It will basically get this remaining part of fifth line from another machine. Okay, all right. So let me kind of try to take this as example. Okay. Okay. So here we are. The way it happens is it happens parallelly. That is something I want to demonstrate to you, that on one node, okay, all right. So there are three machines, one, two, and three. On all the three, this is the block, this is the block, and this is the block. Okay. So now on all the three machines, the input format runs parallelly, and it keeps on moving until either the beginning of the file or end of or the separator is noticed. For example, here it has noticed that it's the beginning of the file, so it will start consuming data from the beginning itself. On the another node parallelly, it noticed that okay, there is no, it's not a beginning of the file. This block is not from the beginning of the file, so it kept on moving. And the moment it hit the first new line, the moment it hit the first new line, it started consuming until until then, until it hit the first new line, it kept on throwing the data to the first node. Okay, it's like two neighbors. Okay, it's like two neighbors. The second one, you have told that in case you don't see the boundary, keep on skipping it for me. I'll consume it. And as soon as you see the boundary, you start consuming it. Okay, so this is the same logic that's running on all the machines. Okay, similarly on this machine, this is also trying to do the same thing. Okay, on every machine here also it will keep on moving until a boundary is hit, and then as soon as the boundary is hit, it will start consuming it. Till the boundary is hit, it will start throwing it to the previous node. Okay, so you can understand that, you can say that this much amount of data, this much amount of data will get transferred to the first node. Okay, question from Jinyang: will it mean the actual block size may be bigger than 120? So actual input split size, there are two things. One is block size, split size. So split size may be bigger than 128 MB. That's correct. So question from Ted, so it will not split the block with the remaining percent block. It will process the full block like block 5. So block 5 is basically fifth line we are talking. It's a 5 record because the meaning of record exists only in the logical one. Okay. One program is trying to split the data by new line. Other program might be trying to split the data by dot. Therefore, so it'll keep on skipping unless a dot is noticed. And as soon as dot is noticed, it will start consuming it. In case of XML, it might keep on skipping unless a particular XML node is noticed. Okay. If the block boundary is just on the fifth node, let's say here, let's say the boundary was actually just here. In that case, just after, in that case, it'll keep on skipping the whole sixth block. Okay. All right. So this is the common logic. So there is a raw data and then there are records. To complete the records, to complete the meaning of records, the extra data is sent from another to the first one. Yes. Anup's question is, so if we say split until the dot, right? So what will happen is the first input split will have the records, let's say fifth one till here, okay, if it fits the block size, not necessarily. Block size is different altogether. Block size will still be 128. And this splitting, this input split will only exist during the lifetime of a mapper or during the lifetime of a mapper. Okay? A question from Saptrishi. The input split could be more or even less than block size. Sometimes, yes. Generally, it is little bigger than the input block, but sometimes it could be even less than that. So that's the logic. That's logic that is there in the input split. All right. So this is what the input split is all about. So Hadoop divides, the MapReduce divides input into pieces called input split. When you are running the program, the data, the raw data is kind of converted into logical things called input split. When we are running mappers, there will be one mapper instance per input split. Split consists of many records. Map runs on each record of the split. Okay, map runs on each record of the split, and small splits, if there are too many small splits, there will be too much of transfer of data and high overhead. And similarly, if there are too big split input split, again there will be too much of traffic overhead, and therefore it will be inefficient. So good size of input split is to be similar to HDFS block. So Thomas' question is how important it is to have the blocks in mind, not just in splits. Like in my local hard drive, I only handle files, not blocks. Okay. So generally, you should keep both the things in mind. Generally, blocks do not matter to you because blocks have fixed definition, but what matters to you is input split. It is important to keep input split in mind when you are programming MapReduce, because this is where the cleverness, or this is where the efficiency lies. Okay? This is where the efficiency lies. Let's say you're trying to store data in XML. Um, it's easier to have XML as the boundary because in case of XML, okay, I'll give this example, right? In XML, we generally have names like this, right? Something like this, right? You guys must have used XML. So you can see that if we say /tree is our /tree is our the point where we are breaking. Okay, so if there are, actually I did a wrong way. Okay, never mind. So I'll just make it as forest. Okay. All right. So you can see that let's say there is a big forest and there are many trees. Okay. And this file is of gigabytes or petabytes in size. And I have actually seen this kind of data in case of a project which I did for telecom company. So they had this configuration of their machines, the towers. So the data looked like this. Every tower and every equipment, and then there was inside every of these nodes there was some config. Okay, and they were trying to use Oracle or similar system to parse it and keep this as a table. Okay, so luckily, since in these cases it's very clear to tell input split that as soon as you see /tree, that means you have hit the boundary, and next one you start consuming. Okay, next one you start consuming. So therefore it was easier to handle this in input split. Okay, but imagine that this was in JSON. Handling this kind of data in JSON is difficult. Okay, so those kind of things you keep in mind. So your data is easier to build input split if your data has clear markers. Therefore, therefore, the Hadoop has come up with new set of formats that I'll discuss that you can use in order to combine multiple data and still have the performance in place. Okay, so choosing a good input split input format is a very important part. Similarly, in what format you keep the data such that creating input split is easier. Okay. Yes, input split, when we create input split, data is transferred between machines. Yes. Okay, but only small data. The smaller the transfer, the better is your architecture. Ted's question is, can the split be configured on whether to process the current data on the current block or for the next block? No, that is not in your control. All you can do is change the type of input split. I'll talk about it now. Okay. Now, so input split is divided into records. The text file, in case of MapReduce examples that we have run, input split contained lines. Record was a line. Okay, a map function is applied on each record. The record is a logical entity and is very similar to the database row. Input format is the class that creates the record. Input format is the class that creates the records. So whether you are using streaming or you are using the normal Java MapReduce, you can set input format using job.setInputFormat class inside your driver logic. Inside the main method of your driver logic, you could say the place where you said job.setMapper. Similarly, you could say job.setInputFormat class. And there are many input format class. Some are provided by Hadoop, and there are many that are provided by many open source projects. Okay. For example, if you have to churn XML input format, okay, the first one that comes from Mahout, this one, okay, this is the one. This is an example, but okay, so there'll be a Mahout library. Yeah, so it's basically a library from Mahout who has created this input format. Okay, so you can take a look. So most of the kind of input format will be available. You will generally not have to write an input format. Okay. So input format takes the raw block, convert it into many input splits, and against input splits, for every record, the map logic will be called. In case of Spark, similar thing happens. Okay. So let's say you want to strictly process n lines in every split. Okay, you want to make sure that every machine gets exactly n number of lines. Then you can use input format called line input format. So far we were only using, by default, if you do not specify any input format, it is text input format class. If you have n line input format, okay, then you can split n lines of input as, make sure that every input split contains exactly n records. Now, sometimes you are processing, fixed length records. Okay, there are many formats in which many formats in which the data is in fixed length format. Okay, specifically the data that comes out of databases, they have fixed size of record with paddings so that extra data can be fit into without resizing the file. Okay, so Mohit's question is, how can every input split have exactly n records? So input format, that logic, make sure that part. Okay, it may be inefficient, but it is possible. All right, it may be possible, but it is it may be inefficient, but it is possible. Okay, a question from Ted: what are the most commonly used input format? This is what I'm going to use. Text input format is a commonly used one, and fixed length format is also commonly used one. Okay, the next one called key value text input format. That's sequence file is quite important. Okay, let me go through. All right. So there are many strategies to break down the input raw block into input splits. Okay. And these strategies run on all node parallelly, and they try to be very efficient so that they don't block each other. All right. Now, when you are dealing with the fixed records, as in every line is exactly of 80 characters or so, in those cases you use fixed length input format. If your raw data is in that format, you use this. Okay. If your raw data that is in the file is in the form of key and value, every line contains key and value. In those cases, you use key value text input format. Examples are like property files and so on. Now, this is something interesting. People realize that if our raw data is in certain nice format, it's easier to handle it. The other need was, in case of smaller files, let's say image files, where every file is hardly 10 KB, 20 KB, 30 KB, and so on. In those cases, it was important to combine them together. If they combine them together using usual, say, zip format, to unzip the data, you need entire block, entire file needed to be on a node, right? Therefore, there was a need of splittable archive. And this is where sequence file input format came into play. Okay, sequence file input format contains a header. It's like a binary file. It contains key and the value. Key is generally the name of the file, and value is generally the entire content of the file. Okay, it has got a header, detailed header. Take a look at the Wikipedia. Take a look at the Apache Wiki. And most of the zip archives and tar archives can be kept in the sequence file. And yes, audio or images are generally converted into sequence file input format. Okay. Sometimes, let's say you are processing a video, so there would be some video input format. And similarly, earlier when I was one of my students was a research scholar at National Labs, which is part of NASA. So they were trying to do a kind of uh, geo geospatial data. They wanted to churn a lot of geospatial data. They were using an input format designed for their kind of formats for the geospatial data. Okay, so most of the binary data is handled using sequence file format. All right, so Hadoop has speculative execution, meaning if one task is not finishing, it will ask another machine to do the same thing. Although it's duplicating the efforts, but effectively it'll be able to finish the work faster. Okay, and The data locality optimization. Okay, data locality optimization is the work to be executed nearer to the data. All right, you see there's a data center which is having 3 rack. What does it mean by rack? Rack is nothing but almirah on which computers are kept. Every rack is a network in itself, and these racks are connected to a central router, and that's how the network is laid out. All right, so imagine that there is a data center and there are racks. So A is the best case scenario whereby the data as well as processing is happening on the same machine, while the second um, case B, the work is getting done on the same rack but different machine. It's not really preferred, but it is better than C. In case of C, the processing and the data are on different racks. Okay, so Anup, was I able to answer your questions? All right, Mohit. All right, wonderful. Okay, so this is called data locality optimization. Okay, a quick question to all: can reducer take the advantage of data locality? Yes or no? The answer is no, because reducer would generally be on different node than the mapper. Okay, and this question which I've asked earlier, if you have to store a file with replication vector of 3, on which all nodes will Hadoop store the replica of a particular block? Yes, yes, data nodes, but which nodes? Randomly on any 3? There are, let's say, 10 nodes in the network. Which 3 nodes will it keep? Okay, so I talked about something called data placement policy quickly earlier. Okay, so first one will be on the same machine on which you are operating. Okay, let's say I'm logged in on e.cloudxlab and I'm saying Hadoop fs minus copy from local. The first copy of this data will be on this machine itself, and second copy will be on the same rack, and third one will be off the rack. All right, and how does Hadoop know where is the rack, and how does it know which nodes are closer? We configure it. We define the structure in the form of tree. Every name of the node is in the form of a folder structure, slash s1 slash r1 slash n1, that kind of structure. Okay, so you can see that there is a switch which is connecting 2 racks, rack 1 and rack 2, and both racks have 3 nodes each. And first node n1 is represented as switch 1 slash rack 1 slash node 1. Okay, so this is how we generally represent every node in the cluster. Okay, so this is also known as rack awareness. MapReduce understands the network as a tree. It is similar to file path slash a slash b slash c. And there is a setting called DNS to switch mapping that provides the translation from machine name to network location. And the config script, you can see that topology.script.file name. This script essentially translate an IP address into a URL. Okay, into a URL. Okay, the URL represents the name of the node in the form of a folder structure. Okay, so quick question to all. Okay, what is the distance between node 1 and node 1? Yes, 0, right? Good. A question from Sub3C: can Zookeeper be used for track awareness? Not really. Zookeeper keeps its own kind of a structure. All right. So the answer is 0. The distance between node 1 and node 2, and the way we count the distance is computed as sum of the distance from common ancestor. So the common ancestor between n1 and n2 is r1, and the distance of n1 from r1 is 1, n2 and r1 is 1, and therefore the distance between n1 and n2 is 2. Correct? Similarly, the n1 and n3 have common parent as d1, so the distance between n1 and n3 is 4. That's correct. Yes. And n1 and n4, imagine there are two data centers, d1 and d2. They have a common parent as slash. The answer is 3 plus 3. Yes. Okay, so this is how you can visualize. Imagine there are two data centers, D1 and D2. This is how it will look like. All right, so that was our quick discussion on Hadoop, Hadoop input splits and the data locality optimizations. All right, so that's pretty much that we are going to talk about Hadoop. All right, we will spend a little bit more time on our Pig Latin. If you want to deep dive, our team must have shared with you Hadoop self-paced course. So in there, we spend a little bit more time on MapReduce. So that would be a little more helpful for you. Okay. Next is all right. Now I would like to quickly take you through Pig and Pig Latin. Okay. And from next week onwards, we will continue Hive and other tools, and then we'll start Scala. All right. Great, great. So should we start our discussion on Pig? Great. No questions? Okay, so yes, I would like to answer this. So when is the long weekend starting? The next week, upcoming week? December 23. Yes. Okay, so I'll show you something. Let me try to take a look at the course. Okay. So here you can see that December 18th is the last date. Okay. So most likely everything will finish by December 18th. Okay. And again, it'll be very difficult for me to take a break for the course, because in case we start extending beyond December, will become a big inconvenience for everyone, because the next week, the December 25th is a time of Christmas, and then holiday, then people will be out of station in January. That's why we will avoid skipping or taking a break. All right. All right. Otherwise, for you also, it will not be good, because it will spill over one more day. Okay. In case there is some inevitability, something happens, we will make sure that we maybe will take extra class in the middle of week or something, but we will make sure that we finish before that. All right. All right. So Ramna, feel free to drop an email to support. Okay. Okay. All right. So So quickly, although this definition would not mean anything to you right now, Pig is an engine for executing data flows in parallel on Hadoop. Okay, and it provides a language called Pig Latin, and it provides the operators like join, order by, filter by. It runs on Hadoop. It makes use of both HDFS and MapReduce. Okay, now, in English, what we observed till now was that for Hadoop, you need to think in terms of MapReduce, not in terms of what we are actually trying to achieve. Even when we have to order by, filter by, group by, or join, it is almost impossible to imagine how are we going to do this using Hadoop, right? And that's where Pig and Hive come into play. So Pig Latin, Pig was a first engine which did it. The, I mean, instead of using SQL, they came up with a newer language called Pig Latin. Pig Latin is very similar to SQL, but planned for distributed computing. Okay, it was planned for general data flow kind of circumstances. Let's take a quick look at Pig. So we have lines equals load data as line, then words equal to for each line, generate words, basically break down whole line into this, and then and so on. Okay, this is how it looks like. It doesn't matter you understand this one or not. The objective is to show you how it looks like. The commands start with double dash, and in every line, first we are loading the data such that there is a single column called lines, and the input file is big.txt. Then we're breaking the lines into one word per line, and then we're grouping the words and creating a group, and then over the group we are doing the counting of each group. All right. So you can see that it's actually pretty simple. In every step, we are doing what we generally do in case of data churning, data processing. Okay. So, all right. So Pig Latin allows us to describe how data flows, how it should be read and processed, how it should be stored to multiple outputs in parallel. Okay, it handles complex workflows. Multiple inputs are joined. Data is split into multiple streams. No if or for loops. Now you can see this. The overall idea is on MapReduce side, we keep on writing the code or use the streaming. On the Piglet inside, we write the logic in terms of join, load, filter, group by, and so on. So it's like comparing C code or your Java code against SQL language. So Piglatin makes the life really easier. Okay, the use case of Pig is ETL. You can do a lot of research quickly on data and do the iterative processing and batch processing. Philosophy is it can handle any kind of data. It can work on any kind of machine. It can uh, cus- be customized and configured, and it is designed for performance. So let's try to launch Pig. Okay, let's try to launch Pig. And how do we launch Pig? We basically go to console and type Pig. This is this is where the you know the pig. All right, is everybody able to see this? Okay, you can try. So this command prompt is very interesting. It gives you the basic commands like ls/data. You can try. So it shows you the listing quickly on the HDFS. Okay, so it could be easily used. Instead of every time typing Hadoop FS, we could actually use Pig console. Okay, everyone with me? All right. So this is how you get started with Pig. Okay. All right. So this is how you start with Pig. There is a local mode that's only for sudo mode. You can pass various arguments to Pig, such as if you just want to run a single command, you could say pig -e. If all the commands of pig, you put it in a file that's called piglatin script, and you can run that using pig followed by your script name. Okay, so pig's prompt is called grunt. The basic construction is that the multi-line comments are just like C, while single-line comments are like SQL. Every processing step results in new condition. Okay, new data set. We call it set or relation. Relation comes from tuple algebra. Okay, so basic construction is every step is resulting in another step. So let's take a look at the actual program. Only then these things will make any sense. Okay, let's take a look at this. There is this file called nyse underscore dividends. Let me take a look at this. Okay, so nyse dividends, this is the file that we want to process. See that? This one. Okay, so I'm saying cat and it has printed what is there inside that data. Okay, so this file contains first column as the stock exchange name, then this is the ticker name or you call it symbol, then the date, and then the price. Okay, good. I actually pasted in a wrong window. All right. Now you can say cat and this and take a look at what's there inside the file. So we are on the pig prompt only. Pig allows us to run the basic commands like ls, put, get, copy from local, copy to local, and so on. All right. So here we are using cat command and to see what's there inside this data. All right. So now what we want to achieve is this. From this data, which is there in this file, we want to compute the average value of every symbol. Okay. I want to run an example first and then talk about the theory. Okay. So this is what we want to do is basically we want to group by this particular column and then compute average value. Okay, sounds like a mammoth task in MapReduce if I ask you, right? You'll have to write Python code, Java code or something else and then compute the average. Now here it's pretty simple. First step is to load it. Okay, let's load it. Okay, all right, let me check if the script is correct. Okay. All right, so let me show you how to run this. So first command is we load the data. We say divs equals to load and the file name. And then we say as these four columns. This is name, this is ticker, this is date, and this is value. Okay, all of these are by default loaded as strings. Okay, done. It's not really loading in memory. That's a misnomer. Don't worry, Ramana, about it. It's just making a note of it. Okay. This, I'll talk about it in details. Okay. I'll answer your question again in details. Then I'm saying group equals group, group divs by the second column called ticker. Okay. If you want to see what's there inside grouped, we can say dump grped. Okay. When we say dump, then it starts running MapReduce job. To take a look at what is there in a data set, you have to say dump, only then it'll do something. Otherwise, it's just making notes. All right. It's like a waiter taking your orders unless you say that I'm done with the orders, get my food. Similarly here, either you say dump or store. Okay. So you can see that it has grouped the data based on our criteria. Okay. You can see Cato has got many records as a group. All right. Then we say average equals to, for each of the group, generate that group name and then average value. Okay, so that's average. And then we are saying store average into this particular folder. Now it says that the folder already exists, which means I might have to delete this rm. Will it work? Let me try again. Yes. So now the moment I said store, it actually started running the process. Okay. Basically, what we are saying is for each of the groups, generate the name of the group. By default, when you're grouping something, the first column gets the name called group. And we are saying average value of the second, the dot value, the fourth thing out of all the records. Okay. All the records from this group. Make sense to you? Okay. So this is how it has computed the results and kept it in, where would it keep it? In a folder called avged. When you say ls avged, you will see that it has created this file. Generally, whenever MapReduce runs, there is a file with zero bytes called underscore success, which signifies is that the work has finished. Okay. Let's take a look at this file. So you can see that it has computed the average value of every symbol. So who all are able to execute it? Okay, Zinyang is done, Ali is done, Manjunath is done. Wonderful. Saptarish's question is, here while you're grouping, we did not have a specific sort the data. Not really. When we are saying group by a particular column, internally that means first sort it and then group it. Or when we are saying group the data, essentially it's considering that as MapReduce. Okay, so there are quite a few things you must have noticed that when we ran the process, when we said store, okay, few things you must have noticed. When we said store, only then the processing started, right? Or we said dump, only then the processing started, right? Because that's what is known as lazy evaluation. We will study lazy evaluation at later point of time in Spark. Actually, Spark is very much inspired by this syntax, whereby you have data sets, you load them, you operate on them, and then you store or do the execution. All right. So, so second thing you must have noticed is that when we said load, it really did not load anything. And these instructions are not doing anything unless a store is called, correct? When we call store, what it does is from this piece of code that you have written, from this instructions, it converts these instructions into a MapReduce job. It, as soon as you say store or dump, then it would basically compute the whole MapReduce job and execute it. So you can see that it's essentially same as our usual MapReduce. Exactly same logs you see. Okay. So in other words, when we talk about Pig Latin or Pig, it's nothing but whatever you, it's a convenient way of expressing the logic, and then Pig will convert that logic into MapReduce and execute it. So, of course, it will not generate Java code. It will basically create the binary and then get it executed. All right. So Pig provides all kinds of data types that are similar to Java's, and it provides complex data types. You should study it if you want to go into more details. And it is little flexible with respect to schemas, so you don't have to define. Okay. So Jamil's question is, what is the extension of Pig script? There's not really any need of extension in any of these tools. Okay, there's no need of extension. Although, as a convention, people keep the extension as .pig, P-I-G. Okay. All right. So there are quite a few details about loading a file, loading from a folder. You can load from a file. By default, in case of dividends, the data was tab separated. So in case you're loading data which is not tab separated, instead it's comma separated, colon separated, you can use pig storage, comma. Okay. and you can load data from HBase, you can load data from JSON file, and so on. Okay, so you can use pig in many ways. All right. So we have talked about store and dump. You can use the dump to display the data set, and store to keep the data in a file. Okay. So for each can kind of is equivalent of SQL select star, whereby you can do the projections. Okay. And you have more details about for each, how to select columns and how to select multiple columns. Take a look at that. And all right, so and take a look at, if you want to go into more details about pig, the video will be made available to you, the course at the usual pig video, but you would not need pig anymore. Okay, this example, if you understand this example, the one which we have run, it should be good enough to do the basic churning. All right, so we will do a recap of pig in the next session, and then we will continue on hive. Okay, those who are interested in digging deep onto pig, feel free to go through the pig details and yeah, as part of the course, or and we will continue our hive discussion. All right. Yes, go ahead, Prashant. So question, Nada's question is related to assignment. So yes. So, all right. So okay. Mm, so there's no time limitation in session 5 and 6. It should be finished before the course finishes. That's the only limitation we have. Okay. So will be in the No Big Data, Thomas. In the No Big Data My Courses, you will find this big Latin presentation. All right. I will also instruct my team to give you the access, share the self-paced course on PIC. All right. All right. Next is a question from Prashant. There is insufficient memory for Java runtime to continue. Yes. Okay. All right. Uh, Prashant, which terminal are you on? F. Okay. So can you try again? Maybe somebody else was running that time. Okay. Let me also make a note of this part. The F gets memory overflow. Okay. We'll just tune pig so that by default it consumes little less memory. Okay. The memory did not occur because we were loading the data. So a question from Jenny Yang, where is this data located? Take a look at Hue. Okay. Take a look at Hue. If you go, if you take a look at the it is located in HDFS in a data folder. If you go to the top level and data, okay, this is where the file is located. All right, I think I missed a few more questions. Karthik's question is, what are those two assignments? Not sure, I missed. I think Nada can explain that. And okay. Okay, great. So this was a great session, although we would like to do a recap of PIG in the next session. I would love to seek the feedback from you, okay? And keep asking questions, and I look forward to see you in the next session. All right? I look forward to see you all, because next session is going to be very important. We talk about Hive, which is more practical way of churning data on Hadoop. Okay. All right. Thank you, Jin Yang. Thank you, Ted. Thank you, Kush. Thank you, Nada. Thank you, Omkar. Thank you, Karthik. Thank you, Nitin. Thank you, Manjunath, Ramana, Sheikh, Sapna, Mohit, Thomas, Prashant. I look forward to see you all in the next session. Bye-bye. Have a great week ahead. All right. Bye-bye, everyone.